So your homework today is going to be work on the take-home quiz. But just to show you what we're capable of dealing with, question 35 from the Ultimate Review. It says the projectile is launched towards the wall as shown in the diagram below. With what velocity, magnitude, and direction does the projectile hit the wall? Apparently, we can handle this, and we can. If I've done my job right, Eric, I won't teach you a single new thing for the next 15 or so minutes. We're going to be stubborn and clever. What's this want us to find, Eric? A velocity. Magnitude and looking at the picture, I think a slanty velocity. Now, depending on where this wall was, it could be if the wall was right here, if the wall was put right there, the projectile would be on its way up. If the wall is put here, maybe the projectile is on its way down. It's certainly suggesting that. So I'm going to sketch the velocity, and I'm going to say to myself, if I had to draw it, I'm thinking that velocity is going to look, hits the wall going down. Ready for the key words, Eric? At an angle. Okay. VY final, not VY initial, because it's VY whatever it's hitting the wall at. I don't know any of these, at least not yet. Now let's look at the original picture they gave me. See the initial velocity? 25 at an angle. Did I say angle? 35 degrees. You know what? I think we're going to break that into components as well. I'm going to zoom in on this diagram here. I'm going to break this into Vx. And this is Vy, but this would be Vy initial. You okay with that, kiddo? I'm really not even sure where I'm going, but I've tried to say, well, there's a velocity, and it looks like a slanty from the picture. And so I figure, I'll draw it, a nice slanty going down. As soon as I drew that slanty one going down at an angle, my brain said, well, components. I may end up also doing a t-table because it's a projectile. I don't know yet. I have a feeling because I'm finding a velocity, a final velocity, I may do the t-table on the fly without actually formally doing a t-table. I'll just make sure if I'm thinking horizontally, I put horizontal stuff in. If I'm thinking vertically, I'll put vertical stuff in. I'd like to find Vx and Vy at the beginning. Eric, my friend, that 25, opposite, adjacent, or hypotenuse. And Vx is adjacent. Vy initial is opposite. Which trig function would I use to find Vx? What would I type into my calculator to find Vx? Ready? Look. Whatever the heck that is, and if you want to decimalize it, Caleb, go ahead, but for what it's worth, if I was generalizing this, Lena, that's what's going to go there! What would I type in my calculator to find Vy initial? So now I've taken you one step further. Now instead of just saying what trig function, take you one step further. And by the way, sorry, I would never do it this fast with this little work on a test, but we're trying to push ourselves. Sorry? Now, that's not Vy final. This is pointing down. So I'm going to make a little note over here. I'll change colors. Vy initial is 25 sine 35? Sure. Oh, I know something else vertically. Yeah. I'd like to find so that I could put it there. I'll get rid of that arrow, but that's where it's going to end up. How many things do I have in my little vertical mini part of a T-table here? I need 3. What else has the picture gave me that I haven't used yet? What is that 40 if you tried to categorize it? Horizontal or vertical? You know what? I'm going to make a little horizontal column, and I'm going to do it right here. Here's my horizontal column. I know that AX is 0. VX was 25 cos 35, whatever the heck it is. Oh, what's that 40? What could I find horizontally that would help me vertically? Time. I love it. About 8 of you glanced at your formula sheet. Good, I've trained you well. And you said, I'm looking for an equation. Nate, which one? Yeah. In fact, I think we said horizontally we could just modify it to that, because A is 0. So if I want to find time, it's going to be horizontal distance over horizontal velocity. And I'm trying, Kieran, to do this as generally with algebra as possible. That would be another generic equation that works for any projectile horizontally. This is why I said the other day, if they give you the horizontal distance, finding time way easier. If they had been mean, what would make this a really nasty question is if instead of giving us the 40, if they had told us how high up on the wall it hit, that would have given us a vertical displacement. That would have given us a full-bore quadratic equation to solve. It's going to be 40 divided by bracket 25 cos 35. And Sarah, if you want it to be uber accurate, this is what you could do if you didn't ever want to have to worry about sig figs. Rather than actually calculating Vx and Vy, you would just keep inputting that particular trig expression. It works. Not much more typing. And I get 1.953 that there, and I'm going to use it. I'm going to write you know what? I'll write 1.95324. 1.95324. And that time value can go here. Eric, what can this help me find now? Vy final. By the way, am I expecting Vy final to be negative or positive? I'm hoping it's negative. If not, I would say, oh, the picture is misleading. It's still on its way up when it hits the wall. And rather than having my black arrow pointing down, I would just have it pointing up that way. I would quickly, scratch out my first triangle, and I would quickly relabel Vx and Vy in that manner. But I think I crunched the numbers carefully here. I think we're okay. I think we're going to find Vy final equals Vy initial plus Ayt. It's going to be 25 sine 35 plus negative 9.8 times t. I used my answer button for time. Show me a negative answer. Yeah. What if I had gotten exactly 0 for my Vy final? What would that mean? The wall was right at the top, just by a fluke. Could happen. So lots of information here, Lena, if we don't panic, if we think about it. So I'm going to go negative 4.8023. And I'm going to move that to there. Change colors, Mr. Dewick. 4.8023. Mr. Dewick, it's negative. Yeah, Lyndon, I got the negative in the arrow right there. What's there? And now I can do Pythagoras. Here, I would probably take the time to go 25 cos 35. Oh, 25. Let's try that again, Mr. Duke. Come on. Cos 35, and I would now decimalize it. Store that on my calculator, and I would say it's that number squared plus 4.8023 squared. Square root. I get a magnitude of 21.0. Theta always goes where the vector is originating from. It's going to be opposite adjacent. Tan again. Tan theta is going to be 4.8023 over 25 cos 35, which was 20.4788. And I get 13.2 degrees. Is that right? People agreeing? No? Yeah? Not above the horizontal this time. What's this? Below the horizontal. So we can handle it. It's doable. Ugly, but yeah. Yeah.
So when you do like the ball tossing equations, you don't write south of east, or you just write.
What we said is that is not technically north. If you wrote south of east, I'd give you marks, but I probably put a frowny face next to it because that is not south. Straight down is not south. We're looking at a picture from the side now. Up is up.
Okay.
So what we decided was we talk about above the horizontal or below the horizontal. But if you said south of east or north of east, I'll give you full marks. I'll just kind of frown at you a little bit. I'll think less of your nerdiness. Okay. So that's just to kind of jog your memory. You can work on the take-home quiz. Let me talk about the take-home quiz. Can you get it out, please? Question 0 says this. All vectors have both blank and direction. Hopefully that's a free mark or close to it. The take-home quiz, the one that I handed out a few minutes ago. Y'all got a copy? Yep. Number 1, a cannonball is fired. Thank you. A cannonball is fired horizontally. I would probably dulp like down here somewhere. A asks, how long is the cannonball in the air before it hits the ground? Find T. B asks, how far does the cannonball travel horizontally? I think that's saying find the range. There's going to be a question very similar to this on your test. Turn the page. Or, sorry, next page over. My bad. A projectile is launched at 28 meters per second at an angle of 58 degrees above the horizontal. You know what? It's launched at an angle. I would probably choose to dulp. Part A asks for the horizontal and vertical components. Part B says, what's the maximum height the projectile reaches? Part C says, how long is the projectile in the air? Other things I could ask, I could have asked you for the range. It's a very easy thing to find once you've done Part C. Could have asked when it gets to its maximum height. Now turn the page. Two forces act upon a point Q. Force 1 is 5 newtons due east. Force 2 is 12 newtons due south. Find the resultant force. Give me the complete answer, magnitude and direction, because force is a vector. 1 mark for a correctly labeled vector diagram, and then 2 marks for the answer. The toughest question by far is number 4. I like number 4. Well, no. Sorry. I like the concept of number 4. on your test, there's either going to be a boat going across the river or an airplane in a crosswind vector application question. Can anybody see why this one is going to be a little uglier than normal? Just by glancing at it? There's angles. This one you're going to have to break into components before we even start to solve it. I'm not going to give you one that tough on your test. On your test, there'll be a nice, lovely right angle SOHCAHTOA triangle, I think. So plane travels 220 meters due east. There's a crosswind blowing at 80 meters per second, 30 degrees north of east. North of what? Find the ground speed. In other words, find the resultant when you add those two velocities tip to tail. But you're going to find when you add them tip to tail, you're going to have a non-right angle triangle. You can solve it using non-right angle trig if you know your sine law and your cosine law. Otherwise, you'll have to break this one into components and then combine the east-west and combine the north-south components and get a resultant from there. Number 5. Projectile is launched from a cliff at an angle. Find the range. I like number 5. I like number 5. I like number 5. My angels, you have the rest of class to work on this.